So I hope you all are fine. I'm Natasha and welcome back. So today we're gonna continue our chapter 1, and that is sets. So in the previous video we did some questions, did some practice questions based on our based on some types of sets, and in this video we're gonna discuss about something new. So let me just let's just take a question that can sets be represented by diagrams? Like, is it like possible? Of course it is. So through Venn diagrams. So in our today's video we're gonna discuss about Venn diagrams. So let's get started. Okay, so first of all let me write the heading, and that is Venn diagrams. Okay, Venn diagrams. Okay, so most of the relationships between the sets can be represented by means of diagrams, which are known as Venn diagrams. Is it clear? Venn diagrams. And one interesting thing is that Venn diagrams are named after the English logician, and he is John Venn. So I think you've heard about him. So he basically he developed this theory of this Venn diagrams are mainly named after him. Okay, so whatever. So let's continue. Okay, so let's take it, for example, like let me make a diagram. Okay, that's gonna be like really simple according to me, and to you also. Okay, one circle in which we have 2, 4, 6, 8, and 10. And in the outside we have 1, maybe I'll say 5, 3, and 7, and 9. Okay, that's it. So as you can see this diagram, so what this diagram is all about. So basically these diagrams consist of rectangles and closed curved things. Usually they are circles. So the universal set will be the rectangle we have, and its subsets are going to be in this triangle. Okay, so I can say that this is a universal set. This means U, which means it is a universal set. Like we're representing universal set. Okay, let me write it again. Looks like the marker is light. Whatever. Yeah, let me just change the marker. Okay, I think it's like a little bit light, so I'm gonna take another one. Okay, yeah, done. So we have the universal set. So, and let's draw one more diagram, which is gonna be right here. Okay. Rectangle in which we have two circles. Okay, so first one we have is A, the second one we have is B. Okay, and this is we have is universal set. Okay, so in the B we have 2, 4, 6, and in the A we have 8 and 10. In the B, in set B. In the universal set we have we have 1, 9, 3, 5, and 7. That's it. And okay, so I think that this is enough. So in the first, these are basically the illustrations that I'm going to tell. Okay, so in the first illustration we can see clearly that we have some let me say this one is set A. Okay, yeah. So in the in the circle, like we have the universal set. Okay, we have a universal set, and its subsets are in this set. So what I'm trying to say is that how we can how we can know that what is it trying to say? What is it trying to tell us? So it's really easy. So in the first one, we have the universal set, which is from 1, the elements from 1 to 10. It is a universal set. Yeah, let me just write it on the board. So okay, so in this figure we have universal set, which has elements. Universal set, so set U is equals to the elements 1, 2, 3, so on till 10, okay, and till 10. So we have total 10 elements. I can say this is 10. 1, 2, 3, 4, 5, and so on. So I'm basically going to say that there are 10. Of course there is 10, because I'm pretty sure about it. Okay, so in the set A we have elements 2, 4, 6, 8, and 10. So which means that set A is a subset. Okay? Got it? So it is like universal set, which is a subset. Okay? So A is a subset. The universal set we have is like let me say that 1, 2, 3, and whatever we have is, they're actually the subsets. You can also see through these things. And one more thing is that 1, 2, 3 till 10. So I can say that these all are natural numbers, isn't it? So of course, I can say that set A is a subset. Oh, got it? And that's it in this one. So in the second one, we have a little, different from our first one. So in the second one, we have, no need to make a line. Yeah. In this figure, I'll say this figure 0, or maybe, yeah. Okay, figure 2. And this was our figure 1, okay? Figure 1. Whatever, but, just so that we can get at what I'm trying to say. Okay, whatever. So in figure 2, so in the second figure, illustration second. Okay, so in the second illustration, we have 2 sets. And mainly universal set we have, and there are 2 more sets, that is set A and set B. So there's like something a little bit, I can say, not like difficult. It's actually, okay, it's actually different from this one. Got it? So not difficult, like in any case, it's just really easy. So we just, we just need to understand and that's it. There's nothing difficult in it. But yeah, it's just a little bit different from the first one we have, okay? So in this figure, what is it? So we have the universal set, okay? So we have the universal set, and this universal set, we have 2 sets. First one is set A, which has elements, 8 and 10. And in the set B, we have the elements 2, 4, and 6. Got it? So actually, in according to set A, we have actually all the elements. So what I'm trying to say is that in set A, so in set A, we have actually, so I can say, as you can see, something is that a small relationship that set A and set B are making is that they are actually the subset. Why? So let me say that in the universal set, so in the universal set we have is till 1 to 10, so element from 1, 2, 3, and so on, till 10. Okay. And in the set A, we have elements 2, 4, 6, 8, and 10. Okay? Got it? And, let me just change their names, okay? So that will be like more better. So I'm going to say this one. Okay. I'm going to say this one as B and this one as A, okay? That sounds better, okay? So according to A, so we have only, 3 elements, okay? 3 elements. Got it? So, and those are 2, 4, 6. But in the B, set B, we have till from 2 to 10. 2, 4, 6, 8, and 10. Till 10. Got it? So in the set A, we have 3 elements, and that is 2, 4, 6. And in the set B, we have 2, 4, 6, 8, 10. As you can see that this isn't actually, this is a subset. So what I'll say is that set A is a subset of set B. This is really clear, and you can even see because in set A we have these three elements, and in set B we have also these three elements. But according to B is a superset of A. Got it? Is a superset of A. Set A. Got it? Okay. So so is there any relationship, are these two sets are making any relationships from universal set? Of course, they're making a small relationship. And that is, let me just tell you. Okay, so in the universal set, we have all the elements from, 1 to 10. Isn't it? But there's a little bit, thing that I'm going to tell you is that, the universal set of which the set A we have and the set B we have are actually the subsets, and what I'll say is that A is a subset of B. And what if I, in the first case, that was set A, and sorry, that was set B, and that was set A. So in that case, in that case, our set B is going to be the subset of set A, and set A is going to be the superset of B. Okay, so just try to make it simple, and so I hope you all understood, mainly about the Venn diagram. So in any case, if we have these diagrams in these circles, which means that they're making a relationship, and they're basically going to be the subsets. Okay, so I'm gonna say that's all for today, and one thing I would like to say is that, in Venn diagrams, the elements, the elements of the sets are written in their respective circles. As you can see, I've written the elements in the circles we have. These are basically the sets. So that we can understand, this is another way to represent sets. So, that's it. So, thanks for watching, and have a great day.